Hello guys, I'm Tech by name and welcome to another repairing video. If you are just watching my videos for the first time, you are welcome to subscribe to my channel to stay up to date on new contents that I drop. So on this video, we are going to be repairing a Redmi Y1 phone that was left with me at the shop by a client. This phone has been with me at the shop for about a year or more. The client brought the phone that the phone suddenly went off and was not turning on. So to him, he thought the screen had a problem. So he brought the phone to me so I could check. And I checked the phone. I told him the screen was not a problem. By then, I was not yet into micro soldering and advanced level troubleshooting and repairs like I'm doing now. So I just told him the motherboard had an issue. So it's only if they can look for a new motherboard or if they can repair it. But at that time, I could not repair it. So I had to study further to see how I can solve this kind of problem. So I'm happy now I'm able to follow up and solve this kind of fault. So it's going to be an explicit video and I'll be explaining with very simple terms that even if it's a beginner, you understand each and everything that I'm doing. So I first of all had to remove the, the unscrew the phone, remove everything, then had to go to my schematic diagram to check if the model was available because I was trying to get the model of the phone so I can troubleshoot properly with the provided schematic diagram or the guideline view from Orion schematic. So right there, I was trying to see if I can open up my Orion schematic to check if the model of the phone was available, and so luckily the model was available, so it made the troubleshooting easier. Sorry, it's taking too much time. I do not want to trim off the video, so I just had to take my time in doing everything that I was doing so some people fully understand. So right there, if you take a look, I've already unscrewed the phone. So the first things first, we had to make sure we check the battery if there was any voltage present on the battery, because those are the preliminary checks you have to do on a phone which doesn't turn on. So the first thing you have to do is to check if the battery has a voltage before you proceed with the troubleshooting. So I had to do the preliminaries and make sure I check the battery if there was current present. And when I check, if you check from the readings above at the right, the top side, we did not get any reading from the battery. This clearly tells us that the battery was completely drained. I don't know why. Maybe it's because it's been long, they have not charged, or probably the phone might have a short circuit, which can cause a current leakage, thus draining the battery totally. Those are the possible scenarios. So I had to hook up the battery on the battery activator so it could be charging and activating while I continue troubleshooting this PCB. So it took me a little while to figure out the exact connector. So I had finally figured out and connected the battery and just plugged it on charge and left it aside before continuing the troubleshooting. So if you take a look, I kept the battery aside for it to be charging while we continue troubleshooting. So when troubleshooting dead phones, you have to be very technical and focused. You have to follow all the steps. You don't have to skip any step, especially if you are just a beginner. So after you done checking the battery, if there's current, if there's no current, or if there is current, the next thing you have to do is to check your VBAT line. Check your VBAT line to see if we have any drop in the ohms reading we are going to get there. So we know if the PCB has a current leakage or there is a hard short on the PCB. So right there, I had to get my probes and set my multimeter to diode mode or booster mode and test the VBAT. If you take a look, we were getting a very good reading for the reverse test. And when we tried the forward test, notice the values were a bit different. So then the next thing to do is I had to connect to the DC power supply through the VBAT test point to see if there will be any current trigger. This will quickly tell me there is a current leakage or there is a short on the PCB. So I quickly had to put put a little bit of flux there and then get my solder wire so I can hook it up there and connect to the DC power supply. Just like that, you have to hit the surface and bring the cable beside the soldering iron so it melts off and sticks to the part. Now next I had to get my alligator clips from my DC power supply, then hook the positive side on the V-bar terminal and the negative side on any position on the PCB that is a ground to see if we have any consumption of the DC power supply. So when I connected, I realized the DC power supply was drawing a very high current. Sorry, I could not show you at this point because I've not yet set a camera that is focusing on the DC power supply. So most time I have to use my phone that I'm recording the multimeter readings to turn around and record the DC power supply reading as well. But at some point in time, I will do that so you guys can fully understand the readings I'm talking about. So I did realize that there was a very huge consumption from the DC power supply. So I had to start feeling on the PCB if any section was getting warm or getting hot. So I'll quickly turn my attention to that direction because since there is an auto consumption on the DC power supply, it can only tell us that there is a current leakage. And if there is a current leakage, which it only tells you that there is a short on the PCB, because current leakage means there is a component that is supposed to be connected on one side. It's now connected on the both ends. So current now flows through the both ends of probably the capacitor or an IC. So I have to start checking the VBAT line from got to check my schematic diagram once more to see the VBAT line so I can quickly troubleshoot the VPH line to see if the short was coming from the VPH line because we already checked the VBAT line and there was no short on the VBAT line, which quickly told us that there is a short. It's either the VPH section or any other section from the after the VBAT section, but it clearly told us that the VBAT line was totally okay. So I just had to consult the schematic diagram once more to check the possible routes of the capacitors along the VPH line so I know where to test and the shields to peel off. So after checking, I had to test a few capacitors and a few components to see the current reading we were supposed to be getting. Honestly, at this time, I could not show you guys the schematic diagram because I did not properly set up all the I did not properly set up the schematic view so I could switch from the microscope view to the schematic diagram. I had not yet fully understood how to use this recording program, but as time progressed, I finally understood how it works out. So I can quickly switch now from the microscope view to a full screen view of the schematic diagram. I have such videos, my repair. I have such videos while repairing Pixel 7 with a short circuit problem, of which I'll post anytime soon. So at this point in time, I felt heat coming up from a certain part of the PCB. So I had to peel off the shields from that area and try to see if I can inject the voltage to feel exactly where the heat was coming from so we could do proper diagnosis and remove the right component that was shorting on the PCB, not by guessing. So once more, I always try to cross-check with the schematic diagram before proceeding so as not to make a very long video or troubleshoot the wrong areas. Because when we have a PCB that is not powering on, the sections we are supposed to be concerned with are just the power section because those are the areas that powers up the phone. So after if we check the VBAT line is okay, the next thing we shift our attention to the VPH line because the 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 charging IC gets its current through the V bus or from the battery itself, and then sends the 3.7 or 4.2 volts into the charging IC, and the charging IC converts this current to the VPH power, which now powers up the other circuits on the phone. There are also other circuits that relies on direct current from the VBAR, such as the backlight section, that is the display section, the network section, and so on. So on removing the shield, I knocked off a capacitor right there, and I wanted to replace the capacitor immediately, but I said no, let me just keep it aside first and troubleshoot the phone. When I'm done, then I can replace it. So that was the VPH line. If you take a look right there, you see the charging IC, and beside it there is a big inductor, which is the VPH inductor. And beside there are other two huge capacitors, which are the VPH capacitors. So I quickly had to check this section since I already saw on the schematic diagram that this was the VPH line. I had to check, and if you take a look at the multimeter readings, you will see that we were getting a beep on both sides of those big capacitors that were connected to the VPH line. So at this point in time, I was totally sure that this was a VPH short, not more doubting anymore, because the VPH capacitors and the VPH inductor was beeping on both sides instead of giving me a VPH value. So I had to take off the capacitor and keep aside. So when I'm done troubleshooting, I'll just stick it back in. I always consult the schematic diagram if it's available so I don't go ahead troubleshooting the wrong areas. So just testing one more time to reconfirm the values, and also to know where I'll inject the voltage to see if we can find the heating component, because once you inject the voltage, the component that is bad, which means it's shorting to ground, that is both ends are now connected instead of one end, will be the first component to take all of the current that's coming into the PCB. That is why the other components that rely on that same current cannot power on because that particular component has used up all the current that was available, almost all the current at times, especially if it's a dead shot, like a 0.00 shot. So at this point again, I had to peel off another shield and check where I'll inject the voltage again to find where on the PCB I'll feel heat coming from, so I can focus more on that. So I had to get my alligator clips and hook them to the multimeter probes so I can easily inject. Alright, so after checking and checking and checking, I had to make sure I inject the voltage now, either from the VPH inductor or those two big capacitors right there. The funny thing about this is while injecting and doing all this stuff, the shorting component was right in front of me, one of those two big capacitors. But since I was just focused on doing proper troubleshooting, and even though I don't have a thermal camera, I really don't recommend the use of thermal camera, especially if you are a beginner, because it's going to make you not know how to do proper troubleshooting. You have to understand how to troubleshoot manually before getting to use all those machines. It makes the jobs easy, yes, but at some time it limits you because without it, you will not be able to do any more work. So you have to get the basics first before getting all those machineries. So I was getting hit from that section. Those One of those two capacitor was hitting, but the hit I was getting bad from behind because I could not think it was coming directly in front of me. I just thought maybe the hit for because I repair mostly pixel devices, and most time when you inject voltage on the VPH line, the short is always around the power manager IC. So me on this video, I was focused around the power manager IC. That's why I failed to see that the shorting component was right in front of me all through. But nevertheless, it made me understood one or two, because when you troubleshoot like that, it makes you understand a lot about the circuit you are working on. Next time, if you get the same PCB, it's going to be relatively easy for you to go through it without even stressing yourself. So again, when I turn the other side of the PCB, I have to check if I'll get any shorting component around that area. So I'll try to inject the voltage from there and check beside the power manager IC if I'll get any shorting component. So I'll just busy testing all those capacitors to see if I'll get anyone that is shorting. I'm still testing. And you have to be sure. You don't just have to. Some beginners, when they get into troubleshooting this kind of fault, any capacitor when they try to inject the voltage, maybe they don't get anything. They just start injecting from any capacitor. If you inject voltage from any capacitor that is not shorting, it's going to send the current to the circuit where that capacitor is connected to. And at the end of the day, you might end up removing an IC because you did not troubleshoot the phone properly. You have to inject the voltage only from a shorting capacitor, so it directs all the components found on that line. The current passes through and it reveals the shorting component easier. So I was just confused. Injecting voltage, the PCB is heating, but I cannot really find where the heat was coming from, so I can focus my attention from there. So I was just doing a hunt. You see, I injected the voltage from there, and I realized the heat was coming around that area, but I could not really place my hands on it. So I had to increase the readings on the DC power supply, increase to about 3 volt and 4 amps, so that the shorting component can heat up faster for me to detect easier. So I had to inject again from that capacitor because it was shorting and it was connected to the VPH line. So when I injected, I had to feel with my hand, and the heat was coming seriously around that area, which was from behind, but I was just there trying to inject, not even paying attention. So I had to come back to the section where we had the VPH, where we had the VPH inductor and the VPH capacitors. So I had to inject again from the VPH inductor, then feel again with my hand if the shorting component was from around this area. It really burnt my hand. If you see, I removed my hand quickly because it really burnt my hand from there, because I had increased the arms to 4 arms, which heats up very fast. So at times these things are really hot and it can really cause you problems. So I had to peel off that shield uh, around the VPH inductor section, not still knowing it was one of those two big capacitors until I had to troubleshoot and inject the voltage the proper way. So it took me a little while to remove the shield. I'm not always in a haste when removing shield, and when troubleshooting devices, you're not supposed to be in a haste. Take your time so you focus on whatever it is you're doing. So I had to normally check that section again since I felt the heat was coming from there. I had to check a few capacitors to see if there was any shorting capacitor around there before I can inject the voltage, because at this time I was really confident that the short was coming from this area because of the heat that really burnt my hand. So I just knew that it could not be elsewhere. It should only be around this area. But then again, when I look at all those capacitors there and the amount of heat that I really felt on that portion of the PCB, those capacitors were really small to carry that amount of heat. But I was just saying, well, since I increased the amps, let me just try and inject the voltage again and see. So at this point in time, since I was really certain that this is the area where the shot was coming from, I had to spray the rosin flux on this area so I don't get to be doing a doubting work anymore. So I had to spray the whole of that area, including those two capacitors that are right beside the. Just had to spray the area. I was really confident if the shot was going to come out from that smoke IC right there, but again, I had so much doubt, so I had to make sure I inject the voltage at this time to see which component is going to heat up first. Then I'll conclude that okay, that's our shorting component. Remember, this work, you don't get to learn it and know everything on a single day. When you start troubleshooting, you start meeting difficult situations, and that's how you adapt. So if you know how to troubleshoot and repair a dead phone, you don't just end there, because there are so many different Android phones. It's not like iPhones, which have probably the same circuit. With Android, there are so many phones that you have to troubleshoot, and so many different systems. So you have to be very vigilant. So now I had to I told you at some point in the video, I'll get the camera to face the DC power supply. So I had to inject from that capacitor, and boom, the capacitor just heated up immediately. I was confused. I'm like, maybe the arms that I said was too high. That is why the capacitor itself heated up, because it's just a coincidence that the first capacitor you're injecting the voltage from is the capacitor that was shorting. It's very rare at times, but it's possible that the first capacitor you inject is where the short was coming from. So I quickly had to spray the capacitor again, then inject the voltage from another section. You remember we are working on the VPH line and it's a rail of current transfer. So if I inject a voltage here and I get a capacitor heating up, if I inject on another component that is on that same line, the same capacitor is supposed to heat up to confirm that that is the shorting capacitor. So since I first of all injected on the capacitor and it melted the rosin flux, I have to inject now from the VPH inductor to see if the same capacitor will heat up, and subsequently inject from the other capacitor beside it. So you see it's the same component that was heating up. So at this point in time, I was really sure that that is our shorting component. But just for benefit of doubt, I had to spray the section again, then inject from the other capacitor beside to see if it's still the same capacitor that's going to heat up, to really confirm that, okay, since it's a VPH rail and if I inject from 2 or 3 angle, the same component is heating up, I mean that's our short. As you can see right there, that is where the short was coming from. So when you discover the short, there are not two things to do. You either have to remove the short, check the PCB if the readings are okay, then you try to switch it on, probably with the charger, the battery, or with your DC power supply. So I had to get my knife, which I'll use to scrape off the capacitor. I really avoid hitting the motherboard these days to remove the capacitor, because we have just a short circuit problem. If we start hitting up this section to remove the capacitor, we might end up causing an open circuit under an IC that might be under that section. So I prefer to just peel off the capacitor and avoid entering into bigger problems rather than the little problem we already had. And also, when you remove a shorting capacitor from a PCB, you have to test why it's on ground with your multimeter. You test both ends to really confirm that that is where the short was coming from. You have to really test to be sure that that is where the short was coming from. So I had to position it and use my probes to test both ends. If we get a beep, it means that, or the reading on multimeter the multimeter, it shows the same short that was on the PCB. So we confirmed that that was our shorting capacitor right there. So now next thing I had to do was to check now the VPH line if we were getting readings or we were still getting a short, because you seeing a short and removing doesn't mean that's the only short. There are times there might be 2 or 3 capacitors shorting on the same rail. So you removing one doesn't mean you have solved the problem. If you check on the readings or the multimeter, you see that instead of the beep we're getting on that section, we are now getting a very good reading. That is a good VPH reading, which means this phone now can power on. I have to check the other components and confirm that the VPH section now was okay. So next, what I had to do was to replace the capacitor I knocked off while I was peeling off the shield. I also avoid hitting the shields because it can cause an open circuit if you hit for so long. So I had to clear the parts, renew the old solder with a low melt solder paste so I don't get to hit that section so much. So if you take a look, that's my solder paste there, very low melt. That's about just 183 degrees melt solder. So I had to thin the parts of the parts of the capacitor. So when I put it, I'll not have to heat for long and it just melts out and sit on the tracks. So once that was done, I had to get the capacitor that I knocked off because I kept it somewhere beside. I was scared at this point that I should not misplace it because I don't know which role it might be playing. It might be a vital capacitor. That's why I had to replace it back. So all you have to do, once there is flux on that area and the low melt solder, you just have to position it in such a way that when you hit it, the solder ball just draws the capacitor and it sits on the parts. You don't need to apply much heat or heat up for long, and that's the reason of the low melt solder, because you get to avoid heating the motherboard, the PCB too much. You just heat a little and everything is set, and you avoid causing more problems than the problems you already have. So if you take a look right there, I will not hit for long and it just sets on its own. As easy as that. That is all. So after that being done, the next thing is either clean the PCB and we test. So I have to get my product, spray on the cleaner and quickly clean those areas that are sprayed the rosin flux. It's always good to do this cleaning. So I just have to clean off the area, clean it up very well and let it dry off. Then I also have to test again because we don't know. Now I have to check the readings again on the V bar line to see if the readings were now normal for both reverse and forward tests. And if you take a look at the readings, everything was now okay. Instead of the current leakage we had before, now we have a good reading on the VPH line. The next thing was to probably assemble the PCB, cool it down. That's my cooling fan. Just have to apply it, put the fan on and put it on the PCB so it cools off faster. You have to cool it down because when this PCB is practically hot, the resistance of those components is reduced. So if at this point in time you test the capacitors why it's still hitting this much, you get very wrong readings. For instance, you notice when your phone gets too hot, there is a notification that pops off that the phone is too hot, shut down device. At times, the phone even shuts down on its own until when it's cold, the resistance comes back from the component before the phone can come on. So after hitting the PCB, you always have to make sure you clean it, you cool it down before doing any checks. So I had to reconnect the I had to place the PCB on in the mobile casing and remove also our battery from the battery activator to check if we now had a voltage on the battery. So I had to change my multimeter to battery mode, to current mode, and test. And if you take a look at the multimeter there, you see that we have a value of about 3.82 and above, which means the battery now had the ability to put on the phone, rather than at the beginning of the video you realize that there was no current present, and this was due to that shorting component that was draining the battery. So once any power gets into the phone, that shorting component tries to feed from the battery or any current that's available on the PCB. So now I had to plug it on charge the ammeter to see if we were getting any reading or if we get any logo from the phone. If you take a look there, that was a logo coming on. So this shows how we had successfully repaired the Redmi Y1 with the VPA shot. So if you have been watching this video from beginning to end, I'd like to encourage you to follow the procedures. If you are a beginner, take your time, don't rush, always do research, go online, watch videos, read books. As a matter of fact, you can contact um, Sergis Mike Tech, who is my main trainer. He is the one that has taught me how to do all this troubleshooting. So big thanks goes to him, and he has a block diagram book which is meant for all technicians that want to do advanced repair and troubleshooting. The book is called The Block Diagram. He has both the physical copy and the hard copy and the soft copy, that is the PDF format. If you are not around Cameroon, you can order the PDF format, which is cheaper, and print it locally at your area. But if you are around Cameroon and you don't want to go through the stress of printing, you can just buy the physical copy. It can be delivered to you anywhere you are in Cameroon. He also runs training programs now. He will be starting physical training very soon. So you can contact him, check his YouTube handle, TikTok, and so on. So thank you very much, guys, for watching, and I hope you have enjoyed every bit of the video. If you take a look right there, you see that's the charging logo we had. I had to snap that off camera and check the charging. You see, we had a value of 5 volts and 1.6 amps right there. So the phone was practically coming on. So I turned the phone on and everything was working. So thank you guys for watching till the end, and stay blessed. Subscribe, share, like, and comment so you get notified for new contents.